Hello everyone. Today we'll be looking at question number 35 from SAT practice test number 5 on the math calculator required section. So let's take a look at the question. A landscaper is designing a rectangular garden. The length of the garden is to be 5 feet longer than the width. If the area of the garden will be 104 square feet, what will be the length in feet of the garden? So now we can break this down into a couple of formulas and just find our given information so we know what we have to work with. So we know that the general formula for area is length times width. We're also given that the length of the garden is to be 5 feet longer than the width. So we know L for length is equal to 5 feet plus W, the width. We're also told that the area of the garden will be 104 square feet. So A for area equals 104 square feet, and then I've just repeated that formula from above right there. So let's take a look at this in a more algebraic way. So this seems like a lot, but we're going to take it a little bit slower. So you know length is equal to 5 plus the width, and you know that the other component of the area function is just the width. So you can substitute L equals 5 plus W into the L times width, and you can equate it to 104 because we're already told that the area is 104. So A, 104, is equal to L, which is 5 plus the width, times the width itself. So 104 is equal to 5 plus W times W. So now you can open up this sort of equation by multiplying it out. 5 times W is 5W, and W times W is W squared. And then you just have 104. So that gives you W squared plus 5W equals 104. Now we're obviously going to need to factor this. So let's make it a little bit easier for ourselves. Let's move 104 to the side where W squared and 5W are located to equate the equation to 0. So that gives you W squared plus 5W minus 104 equals 0. Now we need to think of numbers that multiply by each other to give us negative 104 and add up to give 5. So what are the factors of 104? Or some common factors we can think of are 52 and 2, but that would be too big because 52 minus 2 is 50. Then we have 26 and 4, but 26 minus 4 is 22, which is once again too big. Then we have 13 and 8, and 13 minus 8 is actually 5, and that's exactly what we need here. So we know that our combination will definitely be 13 and 8. But now it only remains to see what we are going to negate and what we're going to keep positive. So we already know that 5W is positive, as told by the plus sign here. So we know that the smaller number is going to be negative because 13 minus 8 will give us a positive number. If we were to do 8 minus 13, that would give us negative 5. So you have positive 13 and negative 8. So you know W plus 13, where W is the width once again, times W minus 8 must equal 0. Then you find the zeros of the function. So when W equals negative 13, the whole equation becomes 0, satisfying it. Then when W equals 8, or the width equals 8, it once again satisfies the whole equation. But we know, since it's a landscaper designing a rectangular garden, and this is more of a real-world problem, our width is not going to be negative. So we can rule out negative 13 as a width. So we're left with a width of 8. So now, since we have the width being 8, we can take our original length function, which is 5 plus the width, and we're doing this because, remember, we have to find the length in feet of the garden. So you can take L equals 5 plus W, and you can substitute our value 8. So that gives you L equals 5 plus 8. So the length equals 13 feet. Thank you.